Well, hello, everybody. Here we are. It's June 6th, 2026, and we have some surprises today. Things that I didn't even know about our speaker, Professor Diego Golombek. I hope I'm saying that correctly. And he will introduce his college by name, his university, excuse me. And he has so many facets. He's truly a Renaissance person. And I heard about him because he was doing a course at Yale as a visiting professor that had to do with various ways to communicate science. But it also said something about bridging that gulf. That's what my whole project is, being married to an astronomer and being in the arts, bridging the gulf between the humanities and the sciences. It's often more like a no man's land with lots of rivalries and ill feelings. So I'm very, very pleased and honored to have from Buenos Aires, or from Argentina anyway, Diego Golombek. And I'm going to turn it over to him. He has slides, and go for it.
Thank you so much, Gloria. Thank you, everybody, for introducing yourselves and for inviting me for this meeting. I'm really proud about it. And the pronunciation was right. And I'm in Buenos Aires, actually. So I'm going to share my slides. Let's see. And there you go. So, yeah, I'm a researcher. I'm a neuroscientist, actually. I work on sleep and circadian rhythms. I've been doing this for decades now, but I also devote quite a load of my time to science communication in different formats, which is what I'm going to talk to you about. Specifically, one format that might be interesting for this group, which is what is the so-called science and fiction, right? So let's talk about science communication first. What are we talking about? Oh, one caveat here. I'm very passionate about this, so I'll just continue talking fast and just stop me whenever you want to. Please don't wait until the end. Just unmute yourselves and just participate, whatever you want to say, question, criticize, or whatever. Okay. So one of my teachers actually coined this phrase, which is science communication is the continuation of science through other means. Of course, this comes from the art of war, right? That war is a continuation of politics through other means. Uh, but it's quite profound, actually, because it puts science communication among the realm of science, right? It's part of science. It's not something different, which would mean that all scientists should be involved in science communication as part of their jobs. But the important thing is, what are we talking about when we talk about science here, right? It's not the same about talking as if we were talking about research, at least for this talk or for this hour that will be around. I would like to define research as professional science, right? That's what I do in the lab, what many of you are very well aware of. And it has its own language, its own communication through papers or conferences or whatever. But it's not the same as science, right? Science is a way of looking at the world, quite playful, quite curious, without the principle of authority. Things are not true in science because of whoever says it, but because it's demonstrated one way or the other. Of course, I'm talking about the natural sciences, not the social sciences, which I know nothing about. And here, what we're not talking about research communication, which is usually done by science journalism, right? That talks about the news of whatever is going on in science. But we're talking about science as this way of trying to understand the world. And that's the science communication we're going to talk about. So in this sense, one definition of science could be science is what happens to you while you're busy making other plans, right? Science is an everyday thing. It happens in the bathroom, it happens in the kitchen, it happens while I'm talking to you through a computer and so forth. Of course, most of you have recognized this phrase, this sentence. It's not mine. It's a very well-known sentence by this very well-known scientist, right? In his last record, John Lennon wrote a song for his son, for Sean Lennon, called "Beautiful Boy," an amazing song. And there is this famous verse, right? Life is what happens to you while you're busy making other plans. Of course, You're not aware of life, but it just happens. Well, the same happens with science. It happens to you while you're not really aware of it. Well, science communication wants to make it aware, right? Wants you to make it aware of what is going on, why, when I add lemon to my cup of tea, it turns to another color, or why do we all sing when we are taking a shower, or now that the World Cup is starting a week from now, what happens with the ball that turns around itself and then goes through a net and so forth, right? That's my definition of science, things that happen outside the lab as well, right? But of course, people are not, that's not the picture that people have from science. There's a very old experiment, it's already 50 something years old, called the Draw a Scientist experiment. It happens in kindergarten classrooms. It's been going on for a very long time, where somebody asks the kids to draw a scientist. Okay, let's forget about drawing. But if I asked you to imagine a scientist, let's picture a scientist in our heads. Well, probably you're all thinking about a male scientist, right? With a lab coat and with glasses and so forth. You're thinking about the archetypical scientist, right? So people don't think that science is an everyday thing. Science is what these crazy guys talk about, right? This experiment I told you about, the Draw a Scientist test, I mean, it's from the early 70s, right, by David Chambers. And throughout many years, the kids drew these archetypical scientists, right? They drew men with crazy looks, with glasses, dirty actually, because they don't shower a lot, they don't take baths a lot, right? But lately, it has changed, right? In 5 decades after drawing scientists, some women are showing up. Some young men and young women are showing up, right? So things are changing because of science communication, because we are changing the way we depict science and the tools we use for science communication as well. Okay. This thing about two views of science. Science is something that belongs to my life or not, is something that's quite well known in sociology of science. And there is a 1959 lecture by this guy, Charles Percy Snow. You might know about him, he's very well known. He actually was a physicist, but he also wrote quite a few fantasy novels. Not that good, I have to say. But his main influence was this lecture that he gave that then became a book, which was called The Two Cultures, right? What are the two cultures according to Snow? One is the scientific culture, the other one is the humanistic culture, and they cannot talk to each other, right? So he would say that this is actually a polar kind of confrontation. At one pole, we have the humanists, right? The literary intellectuals, right? At the other pole, we have the scientists. And the kind of examples that Snow would give were quite extreme, I have to say. For example, he would say that a scientist could really enjoy Shakespeare's sonnets, while a literary humanist, a literary intellectual, could not enjoy the second principle of thermodynamics. I'm not sure if they're the best examples to talk about, right? But what Snow would say is that between these two poles, there is a gulf of mutual incomprehension, right? Again, this was 1959. It was quite a hard lecture to swallow. So about 5 or 7 years later, he changed and he said, well, there might be some ways of communicating, right? We do need to humanize the scientist and simonize the humanist, right? We need to get them together. And actually, science communication is one of those bridges that we can do, okay? However, if you look into literature, into culture in general, it is true that there are two poles here, right? There are two cultures that clash into each other. Let's go into a couple of very well-known examples. For example, one of the examples has to do with this guy, one of my favorite writers, of course, Edgar Allan Poe, who kind of hated science. Actually, one of the only books, no, not one of the only book written by Poe that sold out was a book on science, right? A book on snails actually and shells and so forth that he wrote as a paid writer, right? While his poems and his stories were not sold at all. People were not interested. So this is one of his early poems in which he accuses science of quite a few things, like science, true daughter of old time, you alter all things with your peering eyes. Why preyest thou thus upon the poet's heart, vulture, whose wings are dull realities? How should he, the poet, love you? If you're not allow the poet, you do not leave him in his wandering to seek for treasure in the jeweled skies. And that's what most people think about science, right? Science is against magic, against beauty, against being able to, I don't know, watch a sunset and be moved by it, right? People want to just stay, look at the sky and just think about it. And then comes a cosmologist or an astronomer to tell, well, this is how things work and this is the stars. And they usually don't like that. Or as a neuroscientist comes to tell you what love is or what emotions are. No, no, let me feel them. Don't explain them. So that's what the two cultures are. There is another very well-known example about a literary example about the two cultures that actor Richard Dawkins used for the title of one of his books, this Unweaving the Rainbow, that comes from a poem as well by John Keats, right? A poem in which he accuses philosophy, aka science, of unweaving a rainbow, right? He was talking about, of course, optics, about Newton, in which, I mean, we want to enjoy the experience of a rainbow. Then comes science, right, and divides the rainbow into its primary colors. And that takes away all the beauty of a rainbow. We know it's not that way, right? We know that understanding something is profoundly magical, it's profoundly beautiful, but we do not know how to share that. And if there are two cultures between science and, let's say, the rest of the world, well, what happens with technology? So let's go to an author that you guys know pretty well, Arthur Clarke. He you know about this probably. He wrote the three laws, the three Clarke laws. One of the laws is that advanced technology is magic, right? Which is kind of true, right? How come I'm in Buenos Aires and I don't know, push a button here in my computer and it goes back and forth. I have no clue. It's magic, right? You know that the other two laws of Clarke are when a distinguished but early scientist states that something is possible, he's probably right. But if he states that something is impossible, he's probably wrong. And the other one is the only way of discovering the limits of the possible is to venture a little way past them into the impossible, which I love it. I love the three rules, especially the one about technology. So there is a gulf between science and technology on the one hand and the audience, all of us on the other hand, right? So there are lots of surveys, public surveys on science. This is a paper, it's not a preprint actually, it's a paper in Nature, about the trust in science in many countries, in 68 countries. And actually, one of the things that people agree on is this. I'll turn the laser on. Let's see if I can do that. Yeah. One of the things people agree on is this one here. Scientists should communicate about science with the general public, right? Between strongly agree and agree, we have something like 80%, more than 80% of the people. So people want scientists to communicate, right? We usually don't do it. We don't think it's part of our job. Let's go back to the start. If science communication is part of science, communicating science is part of the job of scientist. So what can we do then? What can scientists do? Lots of things. The first thing is considering that talking about science, communicating science is part of doing science, right? This is not the usual, but it should be that way. Of course, we don't do that because we don't get evaluated for that. When we have to do our reports for our university or a funding agency, we usually don't have any space for talking about science communication activities. That needs to change. We do need to collaborate with the media, right? We don't like each other. To scientists, journalists are people that just say whatever they want about our research and they're not accurate, right? And to journalists, scientists are people that do not want to be understood. That changes a lot. We have amazing examples of wonderful science journalists which are doing a tremendous job of collaborating with scientists. Of course, we have to go to the community, right? We have to go to schools. We have to go to science fairs, to the week of the brain or whatever happens. We usually don't do that. And of course, right, if Gloria invites us, Gloria Milan invites us to the Hard SF meetings, of course we have to come, and I'm proud about it. I'm very happy about it, right? Let's go back. See? However, before we go into the science and fiction topic, I'm saying this as if it were easy, right? As if it were easy to talk about science. It's not. So let me go through 5 or 6 very quick hypotheses on why science is so difficult to communicate or to share or to spread around, right? The first hypothesis: science is very difficult to communicate and to share and to spread around because it changes all the time. This is a biological example, right? It's a concept in biology, in cell biology, called apoptosis. It means that a cell will commit suicide. It will not die old, but some genes will turn on that will tell the cell, okay, you have to die, okay? And this is a graph depicting the number of papers in cell biology that mention the word apoptosis. None, 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 none. A few, a lot. So let's suppose I was telling you, somebody is giving a lecture on cell biology, the life of a cell, whatever, in 1992 or 1990. They will tell a story which is completely different of the story that they will tell you in 1995 or 1998, right? Things do change a lot and very quickly in science. During the pandemic, things changed a lot. Like when it started, immunologists or virologists were telling us, well, you have to wash your hands 10 times a week or whatever, right? Then they said, we now learned that the virus is not spread through contact, but through the air. So now you have to open your window. And that changed within a month, probably, right? So come on, you told me something a month ago, now you're telling me something else. That is one of the reasons why science is so difficult to communicate. Second reason, because it's difficult, right? Because it's for geniuses or whatever. Well, again, a biological example. A systems biology is a branch of biology that studies lots of things together, right? We don't study 10 genes, but thousands of genes. We don't study 100 neurons. We study millions of neurons. And this is a definition of systems biology. System biology is a new field of biology that aims at developing a system-level understanding of biological systems. Who? Again, well, that seems to be said by some character like this. However, that's in an MIT textbook. And it's rubbish, right? It's a very bad definition, circular, tautological, and so forth. But it sounds difficult, right? And we love it when it sounds difficult. And if we love it when it sounds difficult, we also love it when it looks difficult. Final biology example. You all guys know about the Human Genome Project, right? Knowing all of the genes of a cell. Well, genes are tools, right? Or actually are instructions for constructing tools called proteins. So after the genome, people started talking about the proteome, all of the proteins of a cell. But proteins communicate all the time. So then came the connectome or the interactome, right? And this is what a connectome in a cell looks like. Ta-da! Right? And we use this kind of figures, this kinds of images for communicating science. They're useless, right? People won't understand what it is about, but we love them because they look difficult. Also, there is a concept in science which is very difficult to grasp, very difficult to understand, right? Let's suppose you look out of the window wherever you are, in Texas, in Tucson, in Georgia, whatever, and you see white swans everywhere. Your brain is wired to say all swans are white. That's the way we are, right? It's an inductivist brain. However, science always needs to look for something different, for the black swan here. So this thing that is called falsationism, and that's Karl Popper in the bottom, right, is very difficult to understand. Couple more. What we usually get from science are news, but science has no news. Science has stories. This is a couple of photographs of a very old movie called The Return of the Two-Headed Monster. Wonderful movie, right? Which has to do with transplant of heads and so forth. Well, if that happened in reality, what would happen? We would get the news, right? The headlines of news saying that, well, scientists have created a two-headed monster and so forth, right? But that's not news. That's a story. It has to do with, I know, putting nerves together, putting veins and arteries together, and actually, can you transplant a brain? Or is it really the transplantation of a body into a brain, right? And that does not reach the news because we don't have the space or we don't have the time. And related to this, when we talk about science, we talk about science as if it had happened today or yesterday. And this is a wonderful example you might all remember, right? There was a guy called Lamarck who talked about evolution quite a while before Darwin. And the example that they gave us at school was that giraffes wanted to eat the very tall leaves in the tall trees, so their necks would expand, would get taller. So the sons and daughters, the offspring of these giraffes, would have a taller neck, right? And what would we do at class? We would laugh ourselves loud a lot, right? Look at the nonsense that Lamarck is saying. But we are not putting our head, our brain, our mind in Lamarck's time. He was saying that species change. And that was revolutionary. Okay. Finally, right, when we talk about science, it seems that it has nothing to do with ourselves, nothing to do with our body, our emotions, as I said, our kitchen, our bathroom, our bedroom, sports, the garden, music, and so forth. So if we do that, of course, people will think that science has nothing to do with them, okay? When we talk about science communication, there are different ways of talking about it, right? You can talk about journalism, which is talking about news. In Spanish, in many other languages, we talk about popularization of science. So it means that it goes to the people, right? And that metaphor tells something a lot about what we are doing. If it's popularization, it means that it goes from the people that know, the scientists, to the ignorant, the people, right? Communication is very different. The root of communication is Latin, it's communicare. It means put things in common, right? So it's much richer to think about communication, right? And actually in English, in Europe especially, people talk about public understanding of science. So the arrow is inverted, okay? It's not what people tell, what scientists tell about science, but what people understand about science. So your tools are completely different, right? So talking about the popularization of science, there is something that's called the deficit model. Why deficit? Because it assumes that somebody knows what's going on, scientists, and somebody does not. So there's a deficit in the knowledge of what people can grasp, can claim, and so forth. So science communication should cover that deficit And those are the metaphors we use. Don't we talk about translating science, of lowering down science for the audience? So this is not a very good model, but it's usually the way science communication is performed, right? There are many other models, right? Some models emphasize the people that do not know, right? The ignorance, which is the lay expertise model, right? Some models talk about science in context. It's very different to talk about science here in Argentina or in the US and so forth. And probably the richest one is the participation model, in which the audience is involved in the very stories that we tell about science, right? This is very theoretical and it's technical about the people that work in science communication. Just wanted to go here. But again, sharing science is telling stories, right? So let's move from here. One of the ways of thinking about this is putting science on the one side and the world, the public, the audience on the other one. And what kind of conjunction did we use? What kind of prepositions do we use between science and the world? That will define the way we talk about science. There are many of these conjunctions or prepositions that are very useful. For example, if we talk about science about the world, around the world, besides, for, of, and the world, that will lead us into a new way of talking about science, right? Because it has to do with what people live, what people feel, what people like, including literature, okay? My favorite tool for science communication is what I like to call smuggling science, right? Which means you won't go into your audience saying, well, I'm going to talk to you about physics or biology or chemistry, because people usually don't like that, except for a bunch of people that are fans of science, right? But if you tell your audience, wait, I'm going to talk to you about sports or about cooking or about music or whatever. Okay, I'm engaged with that. I like that. Okay, so I'm telling you what science has to do with that. And it's usually very successful as a tactic for talking about science. Okay, there are many effects in science communication that have proper names. For example, the Sagan effect. You all know very well Carl Sagan, amazing guy. Uh, the Sagan effect talks about scientists that get very exposed to the public, and then the academia turns their back to them. Sagan was not allowed into the National Academy of Science, for example, probably because they were very jealous. I mean, you're famous. What do you want to do with us, right? Then there's the Hawking effect. You know, Stephen Hawking, very well known because he appeared 3 times in The Simpsons, right? And the third time, Homer Simpson welcomes Hawking, say, "Oh no, that crippled guy again here." Amazing guy. Hawking effect means about some products of science communication that are extremely popular. They sell out, they're bestsellers, but they're very difficult to understand. The first book by Stephen Hawking, A Brief History of Time, was a bestseller in all languages it was published. However, very few people read it because it was very hard to read. So people want to know, well, why? Why is it so popular, so forth, right? And the third one is the Asimov effect. Again, a guy you know very well, which is the effect that claims that scientists are entitled to talk about anything, right? You know, besides his novels and his stories, Asimov would write about anything. He would not only write about the Bible, about biology or the chemistry, but also about religion and the Bible and whatever, because, I mean, he's a scientist, you know, he's Isaac Asimov, he's entitled to do that. And people get kind of angry when scientists tell them, well, I don't know anything about that, right? So these are some of the effects we study or we talk about in science communication studies, right? Then we go into books, right? One way of doing science communication is writing books, of course, right? This is not new, right? Stephen Jay Gould, who is a very, very well-known evolutionary biologist, He wrote in one of his books that the pioneers for science communication were St. Francis, right? Because he had a story to tell and nobody cared about it, but animals. So then he started talking to birds and so forth, kind of a joke. And then this guy is Galileo Galilei. And why is he a pioneer? Because he did something that nobody had done. First, he wrote his science in Italian, not in Latin. Why? Because he wanted everybody to know about it, what he was doing. And second, he wrote literature, right? For example, this one here is a dialogue, and it's written as a dialogue. And one of the characters of this dialogue is a guy called Simpleton. Why Simpleton? Because he does not understand anything about what the astronomers are talking about. So Galileo has to go the extra mile to explain things in a very easy way so that he would understand it. And the simpleton is, of course, all of his readers, all of the audience out there. Then in France, things were going on as well, right? There was the encyclopedia, the Encyclopedia by Diderot, right, which wanted to convey everything that was known at that time. Also, Voltaire, the very well-known philosopher and writer, was translating Newton into French because he wanted his French compatriots to know about what was going on in science. And then there was this guy, Fontenelle, who wrote a wonderful essay on the plurality of worlds. And I want to talk to you about the introduction to this book. He says, this book has to do with my time in the country, in the palace of the Marchioness of G. And what do you expect? Of course, you expect parties, you expect horses, horse riding, and so forth. No, you expect parties, gambling, or hunting. You will have planets, worlds, whirlwinds. It has hardly been discussed otherwise, right? So he's trying to change the way people think about science, and we are talking about the early 18th century here, right? If we talk about science books, right? Not science and fiction yet, but science, popular science books. You can talk about age, audiences, authors, and so forth, right? However, if you go and look into a bookstore, where do people book science book? It's very random, right? For example, if you go to look here in Buenos Aires at a bookstore for a book on what I do, what I work on, which is biological rhythms, this here is a book on biological rhythms. It's called Biological Rhythms. Look who are our neighbors. The aloe vera miraculous plant, predictive astrology, Ernesto Che Guevara, very well-known chronobiologist, of course, and this one here, the big book of cooking, right? So that's where at least some bookkeepers put science books in there because, well, why not, right? So also, there are some topics that do not fail if you write a popular science book. And I wrote many books. I wrote 20-something books on different topics of science and scientific culture. People write about cosmology, catastrophes, mental health. Mathematics has become quite a hot topic, actually, and physics, right? But beware when you look at a popular science book on physics, because especially if it talks about quantum whatever, oh, be suspicious, right? Because since it's a very hard theory to understand, people have claimed that quantum physics is everywhere, and it's not. Okay. Some classics, some classics that have really passed the test of time. A book on Einstein in which he wanted to tell people what is relativity. It's not that easy, actually. A book by George Gamow about quantum physics, in which he imagines a scientist that gets reduced to the size of an atom, so he can go inside the atom and looks what it looks like. A book by Doxy Thompson on how do animals grow, and of course Double Helix by James Watson, which was written as a bestseller, right? It was written for people to read, right? And to read as a novel. And some of these classic books on science, right, were very influential. For example, this little book from the 1940s by Edwin Schrödinger, a very well-known physicist, about life. He started questioning, I mean, what is life according to a physicist, right? And it's claimed that this book is what turned many physicists to go into molecular biology. For example, Francis Crick of the Watson and Crick fame, right? So it was very influential outside its little niche, right? The selfish gene by Richard Dawkins, which claims that the gene is what moves evolution, actually. People claim that this book was one of the cornerstones for doing the Human Genome Project, right? Silent Spring by Rachel Carson. Why Silent Spring? Because one of the metaphors that Carson used is that birds had stopped singing in the US. Why? Because DDT was being used as an insecticide widely everywhere, right? So out of this book came the prohibition, the banning of DDT, at least the way it was being used at the time. It was very influential, and it's a popular science book. And finally, this very well-known book by Jared Diamond, Guns, Germs, and Steel, in which he claims that part of the conquest of America, of America, the continent, not the country, had to do with infections that came from Europe. Out of this book started quite a few research lines trying to understand what happened in this clash, not of civilizations, but of germs, right? So out of this book, some scientists starting new experiments. So sometimes writing about science can have very profound consequences, okay? So if we are communicating science, we need to take care about the language, the style, the metaphors. We might need humor, characters, and so forth. So writing about science is actually literature, right? It's not a different genre. It's also literature, okay? So we do have to use literary resources. We have to use history. We have to use humor. We have to use art, analogies, everyday life. We have to talk about popular culture. We have to desacralize science. And good science communication has all of these ingredients. What kind of authors am I talking about? Well, the periodic table by Primo Levi, books by Richard Dawkins, my personal favorite and hero, Oliver Sacks, Alan Lightman, Carl Sagan, Mary Roach, Olivia Hudson, the many authors that can relate to this writing science as literature, even as fiction. So this is what I wanted to talk to you about, the concept of science and fiction. You're very accustomed. I mean, this group usually doesn't use the in word, right? You use science fiction or maybe science-fiction, right? And that's a very well-defined literary genre, has to do with anticipation, thinking about the future, the very distant future in general, right? But this is not science and fiction. Science fiction is a concept that has something like 30 years, is 30 years old or so. It was put forward by this guy, Carl Djerassi, amazing guy. I know Gloria knows him very well. Carl Djerassi was a chemist, an Austrian chemist that escaped Europe in the verge of the Second World War, ended up in the US, also in Mexico, and he is very famous as a chemist because he invented the contraceptive pill, right? So he invented that in Mexico, then went back to the US, and he was very rich. He was a millionaire for sure. But he was also very interested in the arts, in literature, in plastic arts, in theater, and so forth, right? So at some point in his career, he devised this notion of science in fiction, which means fictionalizing science, right? For many reasons. One might have to do with science communication, okay? And as I will say, it's a very strong tool for communicating science. The other one is because it adds credibility to a plot, right? If you're talking about something that has to do with science, and it's real science that it is in there, people will read it very differently, right? So this is a quote of one of Djerrassi's papers in regarding science and fiction, in which he says, "I call my genre science and fiction to distinguish it from science fiction. As a tribesman," because he says that research is a tribe, are tribal, right? The traditions of research are tribal. "I demand of myself a degree of accuracy and plausibility that impart to my storytelling a high ratio of fact to fiction," right? You guys are much well versed in science fiction, that for sure myself, right? And I'm sure that when you read a science fiction novel or story or whatever, and the facts are not right, you don't like it, right? You kind of get crabby. I mean, this cannot happen, right? There is no sound in 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 the vast universe. So how come in Star Wars you hear all of these explosions and so forth? So science in fiction demands credibility, demands science, and it's not necessarily something of the future, right? So let's go to a few examples of this science in fiction notion. First, actually, Djerassi did not invent the notion. There is a paper in Science from 1922, in which the author, which I don't know, this Edwin Slosson guy, says that, let me talk about different definitions or different examples of science and fiction. For example, science fiction, right? Fantastic and futuristic fiction, such as Jules Verne or H.G. Wells and so forth, okay? But then, second example, novels based upon some scientific discovery. Well, that's science and fiction for sure. Third example, stories in which some scientific fact or theory forms the theme. Again, that's not science fiction. That's science in fiction. And four, it could be historical fiction, where a distinguished man of science plays an important part, right? Where there are quite a few out there, again, science in fiction. That is not what you would define as science fiction, right? So again, for more contemporary examples, there is a very well-known French author called Michel Houellebecq, who has been translated everywhere. Before becoming a very famous writer, he would work as an agro-engineer. He would work in INRA, in the research agency for field studies and country styles. So that's why he knows that much about science. This novel, The Elementary Particles, does not only have the title related to science, but the plot is very related to science, right? David Lodge, this amazing British author that does science and fiction, but actually from the social sciences and humanities point of views. You can read about what a conference is like in the humanities and social sciences, Department of Literature, of English or whatever. And this particular novel, Things, has to do with cognitive science, right? And he's very well advised because everything that he says is very accurate in terms of neurocognition and so forth. A very recent novel by the Chilean author Benjamin Labatut, The Maniac, right, who has to do with invention of computers. Again, very well referenced, very well quoted, very well advised. I mean, beautiful novel. I strongly suggest its reading. Then some of the science and fiction literature has to do with philosophy of science. This amazing author, Rebecca Goldstein, she's a philosopher. I believe she's also the partner of Steven Pinker, sorry, another philosopher. And some of her fiction books, like this one, The Mind-Body Problem, have to do with philosophy of science. And maybe one of the most well-known examples, Michael Crichton, the guy from Jurassic Park. Michael Crichton used to work at Harvard in medical research. His books include graphs, include photographies, include very, very accurate data that comes directly from the sciences. So being a scientist or not, as a reader, you do get really touched by it. Oh, this seems to be serious, right? One of his early novels is this Determinal Man, in which he talks about a man who has convulsions. He's an epileptic, and so the scientists um, kind of devise a pump that is not a pump, a stimulator that is surgically implanted into his shoulder, that whenever a convulsion, a seizure is going to start, it injects a negative current, something like that, into the area, right? And it's so accurate what he says. There are some EEG recordings in the novel, and it's very good for the fiction, not only for the science, right? So I claim that this is a wonderful opportunity for science communication as well, right? Even for science classes, right, at schools or in universities, why don't we give our students one of these examples, and then we go into the science behind the fiction, right? I do that with my students, and it really works, okay? Then again, science in fiction allows you to discuss other areas of science, like, for example, scientific ethics, right? This is a paper from a few years ago in which the author talks about what kind of ethical problems can we dissect, can we draw from fiction, right? About Dr. Frankenstein, Dr. Moreau, informed consent, right? Experiments that were done without people being aware of the experiments, clinical trials, and so forth, right? So it's a very strong tool for discussing ethics, going from fiction, going from literature, okay? There is another literary genre which I like very much, which is microfiction, right? Which is characterized by extreme brevity, usually about 100 words. And it's such a wonderful experiment, with a wonderful tool to teach about science, to think about science, to think about literature. There are so many examples of science in microfiction, right? Well, for example, one of the main, the most well-known microfiction stories is from a Mexican. No, actually, he's not Mexican. He lived in Mexico. This guy Monterroso, who wrote a seven-word story, which translated would be something like, "When we awoke, the dinosaur was still there." I mean, that tells you a complete story, right? Then a very well known by Ernest Hemingway, "For Sale, Baby Shoes Never Worn," or Joyce Carol Oates, "Widow's First Year, I Kept Myself Alive." Well, that's not very scientific, but we do have scientific examples. Our hero, our national hero, Jorge Luis Borges, which is one of the most important writers of fantasy, not science fiction. He wrote so many short stories that have so much science within it, like Unexactitude in Science, or Franz Kafka also wrote very short stories that have a lot of science within it, right? And there are some contemporary examples. This comes from a literary contest, which I found, that have really very strong short stories that also have some science within it. So I did a very short experiment. I asked AI to write microfiction that had to do with science. They're quite interesting examples, like the last robot learned to weep, or the universe was a simulation. I just sent a bug report. Or he had all the memories of his dead wife. He was not the same man, right? This was written by ChatGPT, right? So there, as I said, it's really a very strong tool. It's not only fiction. What about poetry? Of course, poetry is such a strong way of communicating science. And it has even reached academia, right? There are quite a few books that talk about how to communicate science through poetry. There is one particular British author, this guy, Sam Illingworth, amazing guy, really. And he is the editor-in-chief of a journal called Consilience that is published quarterly or something like that, that has to do with poetry in science, and I definitely recommend you to go through it. There are so many examples. I won't go into that. Okay. What about drama? What about theater? Well, I believe theater is probably the strongest way of communicating science, even stronger than literature, because things happen there. They're physical, right? Copenhagen, right? The very well-known play by Michael Frayn was a success everywhere. It sold out in all countries where it was performed. And it's a very hard play. I mean, it talks about quantum physics and relativity and Heisenberg and Bohr and so forth. But something happens with the audience, right? When we're looking at these guys discussing and being there, being present, I cannot think about a strongest way of communicating science. Or Constellations by Nick Payne, a beautiful play. Oxygen, not only by Carl Djerassi, the guy we talked about, but also by Roald Hoffmann, which is a Nobel Prize awardee in chemistry. Proof, a wonderful play about mathematics, which I believe is having a run in Broadway these days. This much I know, and so much. It's really very successful. And within theater, of course, musicals can work and opera can work, right? And as Gloria was saying, I wrote the script of an opera uh, on Darwin in Patagonia, on young Darwin, right? Because when we think about Charles Darwin, we think about a very old guy in his house writing and sending letters and whatever. Well, he was 21 years old and he left his house for the very first time to go around the world. And he spent months in Patagonia, in the south of my country, and his discoveries are absolutely amazing. And I do believe that for the audience, looking at this, listening to the music, and thinking about what was going on in his mind is a very different experience as reading The Origin of Species, right? Of course, films have been used a lot for portraying science. Some are amazing, right? These are some of the examples that I found, but you will know many of those. And some are quite surprising, like, why do I put Finding Nemo here? Because it's very accurate. And Dory, Nemo's friend, has some kind of anterograde amnesia and short-term memory problems that are very accurate, right? So why don't we use that? Why don't we use that in classes or as a tool for talking about science? Okay. So in summary, all tools are needed and welcome for science communication. And especially, I want to attach, to put at the front here, science in fiction, right? Using fiction for science communication, or on the other hand, right, using science for adding credibility to fiction, but good science, right? Talking with the experts, knowing what we are talking about. It's basically a matter of tactics, of strategy. That's what we are talking about when we talk about science communication. And if we talk about tactics and strategy, I want to end with a poem actually called Tactics and Strategy by a wonderful Uruguayan from Uruguay, poet called Mario Benedetti. And let's read this poem thinking about science and science communication. My tactic is to look at you, to learn how you are, to love you as you are. Of course, we have to learn about our audience. We cannot go and look to our audience from a very high mountain because we know what it is about. My tactic is to talk to you and listen to you and construct with words an indestructible bridge. That's science communication, constructing a bridge between science and the audience. Remain in your memory. I don't know how, nor on what pretext, but remain in you. To be honest, to know that you are honest. So between the two of us, there is neither a curtain nor an abyss. So what about strategy? My strategy is more profound and more simple. My strategy is that one fine day, I don't know how, nor on what pretext, you, the audience, will finally need us, the scientists. Thank you so much for listening. And I'm open to discussion, questions, comments, or whatever.
Wow, this has been very enlightening, but also very enjoyable. I hope we have a few questions from the floor here. Time's open. Come and ask. And while they're thinking about their questions, do you know that we have an online YouTube-based classical science fiction theater group
Oh,
called
great.
Planet Zoom Players. I'm low on bandwidth, so I won't put the link, but it's just you put in Planet Zoom Players or PZP in YouTube. We're
I
working
will.
on Carl Chopek's RUR, Rosum's Universal Robots, and it will be released in 4 parts because we're doing a good job. We're really doing it. And as you know, this has some good science in it, but the effects on humanity of automation is very accurate, I think, in RUR. Although it isn't all negative because it gets to that maybe the robots will become us. It's a new form of us, and it's not just Frankenstein redone, is what I'm getting at. But anyway, it's a very that's the one thing you hit on that I was so amazed because theater has gone away, and actually that was so formative in the field of science in fiction or science fiction was RUR. It was everywhere in 1920, 21, and that's where the word robot came from,
Yep.
was that play. So, and people forget it was a play, it wasn't some fiction. And I think your points are so well taken that I'm stunned because I've had a lot of these thoughts, but never put them so well. I'm sure we have some questions. Nancy, Chris, anybody? Starlet. For one thing, we're so happy to be. This is our first connection with Argentina.
Good.
And I do have a question while they're still thinking of their questions. Is there a history of Argentinian science fiction that you would point us to? Or do you have some anecdotes about that?
There is a history. There is a strong science fiction community in Argentina, actually.
Mhm.
And it's in Spanish, though, but I can certainly send you, there might be a link to some internet site. I look for that, but there are people that have done some history of science fiction in Argentina. So I'll look into that and send it over.
Oh,
It's in
yeah.
Spanish, but with AI, you can probably translate it
Oh, and no
pretty
problem.
easily.
You can
Yeah.
use, Google Translate or whatever.
Yeah.
So yeah, I know that there is, and I think this is part of the problem of making science fiction or even science in fiction truly global is to move out of our linguistic silo vision that everything is US and everything is in English. We're trying to get beyond that. I see a hand. Okay, Starlet.
Um, Hola Diego, cuánto me alegro de verte aquí, ver a un hispano. Hello Diego, I'm so happy to see you here, a Hispanic.
Thank you.
I wanted to say that at the beginning of the presentation, I was feeling like, okay, I'm going to stay quiet and keep on listening because I was like, no, I am a poet and a fantasy writer, but what I write in my fantasy when it has to do with science is accurate. I love science. So, and I find the beauty in science. So for me, knowing how rainbows exist, how they come to be, is not a deal breaker. For me, it's like, I love it. I see the poetry in it. So I was just feeling like, okay, so I guess if my last name is Swan, and I chose that on purpose because of my favorite writer, Hans Christian Andersen, but I'm also a black swan. So I'm like, I was just going to suggest have or ask you, have you gotten in touch or do you work with creative writing, not journalists, but creative writers to bridge the gap between the people at large and scientists. Because what I'm trying to say, scientists, they're professionals and they study things very rigorously. And they may only see it sometimes from their own point of view, and they don't know how to translate that for everybody else. When you are talking about a journalist, they are trying to be accurate and objective, which is very good, but it doesn't really mean that they're going to be able to grab the audience. But creative writers, we're artists, and what our main thing is to connect with the audience, to have the message come through. So my question to you is, have you partnered up with creative writers in order to bridge that gap?
It's
Because
a wonderful question, Starly. I haven't actually. Uh, I well, actually, I'm doing that right now with a Mexican writer who lives in Spain. We are writing a book on the natural history of the night,
Mhm,
and I'm adding the circadian biology or sleep part of it, and he's adding the literature, the creative writing about that. But you said about journalists, I completely agree. Uh, but usually, because news are only devoted to talking about the what was your discovery, and there's no space for the how. And science is how. How did you reach that conclusion? And usually we don't have any space. We don't have any time for talking about that. So yeah, I completely agree that it's very difficult. One another thing that should be said is that of course, we want to understand the details of a research. I never understand what a physicist does or a geologist or whatever the details, but I think we are all entitled to understanding the question that he or she is asking. What makes the scientist rush to the lab every day? What's so passionate about it? If we cannot understand the question, something is wrong with the scientist, not with us, right?
mhm.
But again, yeah, it would be wonderful to team up with creative writers for doing science communication. And I'm not that aware of many examples. However, I am aware of examples in the science in theater um, um, area, right? And the other thing, if you read, I don't know, Ian McEwan's novels or David Lodge or whatever, and the acknowledgments always mention scientists, right? I'm grateful to this doctor whatever because she told me about what it's like this or that or whatever. So it happens that way. I mean, creative writers do rely on scientists for accurate facts. It doesn't happen the other way around, which is what you're just suggesting. And I think it's a very interesting suggestion. Thank you.
Well, I would like to say that if you would like, if you're looking for people to bring this to a reality, I would love to collaborate.
That's wonderful. Thank you so much.
Okay, I have a couple other potential collaborators here. I don't know which of you had your hand up first, Melissa or Sarah. You know, I'll just call on the first one I see, which is Sarah.
Yeah, hi. Excuse me, sorry. I wanted to add in that, I come at this from a somewhat, well, not unique, but I studied both space science and creative writing. Um, so I'm sort of approaching this from both sides. And it's my dream to create a collaborative community between scientists and writers so that we can get the science in fiction correct. Um, and that's part of my PhD and part of my not outreach, that's not the word I want, but part of my impact that I'm hoping to achieve with my PhD. So I don't exactly have a question, but may I drop you an email and perhaps we could look at, some sort of collaboration in the future.
I'm writing down my email address in the chat. So yes, of course.
Wonderful, thank you.
Sarah, do I have you on our list, by the way?
You
Maybe you
do,
saw, you're sure
you
you're
do.
on our list. You get our, okay.
Yeah,
Okay, well, I'm going to go to our next hand who hasn't spoken yet, and that is Melissa Tolliver. Are you still here, Melissa?
I am. First, I not so much of a question, but I just wanted to thank you um, for what all you've had to say. It was very interesting to me and very enlightening. I came to science fiction and science. I'm sorry.
No. Go ahead.
Oh, my father was very, very interested in science and science fiction, and he tried to pass that on, which he did very well. But one of the things that you were talking about, Isaac Asimov, one of the things
Yeah.
that gave to me was that you can be interested in everything. You don't have to just be a physicist. You don't have to just be a particular kind of scientist. I used to laugh when I had to write papers and things in high school because I could just go to nonfiction, Isaac Asimov, and find it. That was in the library. There was everything. I once had to write a paper on a paper for my, I guess it's for my chemistry class, because I didn't want to do the butterfly thing where you have to catch butterflies, and I told her I was morally opposed to that. But anyway, so she said, "Go write something," and I was like, "You can write me a paper on anything." I panicked. But again, I knew that my Isaac Asimov would save me. I went and looked, and he had a book on nitrogen. Who knew? Nitrogen. So I wrote an entire paper on nitrogen. But it really has influenced me, especially with my own children, and we homeschooled, and with my grandchildren, to make sure that they understand the value of science, not just as because we need to know it, but also as a way to enter fictional worlds, and as a way to find out about things and to be very generic. Carl Sagan did similar things too. Anyway, I just wanted to thank you so much for what you've said. It was so interesting.
Thank you so much, Melissa. Beautiful comment. Thank you.
I also have a comment. I knew Isaac Asimov, and we used to correspond a lot because maybe you don't know this, Diego, but he would take up people that were struggling. I was going through school in a cold water, drafty flat in Gary, Indiana, and he used to write me sometimes a card a week to keep my spirits up. And I know that he did this for maybe, I don't know, hundreds, if not 1,000 people. And I'd bug him. I would think of a question just to get an answer, and he would answer a lot of the time. And so I don't know how much I can say about that when other people, there are women who will say he pinched me at Balticon, stuff like that. But and that was a different culture too. But anyway, yeah, and he confided in me that he wrote this book, Asimov's Guide to Shakespeare, and I was an English literature major, and he told me how cruel they were being to him. And he said, I'm not trying to displace the Shakespeareans. They have their own discourse community and their own things. What I'm trying to do is bring in the science of that day, which, none of them would do. And he said it's kind of complementary, not overlapping. And I commiserated with him, but evidently he was quite hurt because he worked very hard on that. So just so you know.
Oh, good.
His guide on Gilbert and Sullivan. Who knew?
Yeah, no, he was sort of a man with a lot of reading, because he may have been, if we were going to get into diagnoses, he didn't like the outdoors. He was, sometimes people would say, a mild agoraphobic person. And because of that, he just did what Ray Bradbury did. And he did that too, go through the whole library. But Bradbury did it more in the humanities. Asimov did it in the humanities, but also all over science. So there's some rules, and there's some rule breakers about getting into other people's discourse communities. I think that was a big shock for Asimov. He didn't realize how territorial those things were. But anyway, I won't go on about that. So there's a hand here. I think Starlet may have another question, or Melissa you already had your hand up. Starlet,
Yeah.
did you have your hand up a second time or no?
No, but I was thinking of a different question.
Well, okay.
It's like you were reading my mind.
Okay, good. Well, I've not any better mind to read than yours. Go ahead.
Oh, thank you. That is too sweet. Well, I found something that was weird, and I would like to know your take on it. I have written a couple of stories that are science fiction. In one of them, I was explaining um, the transportation, let's say that. And on another one, I was explaining, because that one was quantum based, basically.
Okay.
And I was explaining about a battery that in reality doesn't exist, but there's a lot of research that is being done, and they're hoping to make it a reality. So when I wrote the story, I chose to use that battery as if it existed, which I think is fair to do.
Of course.
Um, because I do believe that in science fiction, if we don't have fantasy, we cannot perceive a different type of future. And so for me, the fantasy was bringing that battery into reality. But when the feedback that I got back was, we like the story, but remove the science explanation, remove the science. And I haven't removed it. And I have just been, okay, what do I want to do? Do I want to get the stories published? Or what? So the thing is that, have you encountered that? What is your take on having science fiction stories and have the science literally being removed?
Well, but it's not the science, it's the fantasy that they ask you to remove, I guess. It's fiction, it's literature, and everything is valid. I mean, what I would say is that I personally, as a reader, I prefer science fiction stories or novels in which I kind of smell that the science is accurate, right? That somebody advised the author, or the author is a scientist or whatever. But that's a personal take, actually. So no, of course, you shouldn't take away the science. I mean, that's the richest part of literature in general and science fiction in particular. So I'm so sorry that they told you that that they told you to remove what maybe was the most creative part that you put into that story. But well,
Well, I think I'm going to just keep it and hope for
yeah,
the best.
Well,
yes,
you can always, try other markets for it that wouldn't be that judgmental in that area. There's so many markets out there. A friend of mine told me there's a niche for just about everything. So try another one.
I will do that.
Yeah,
And
keep trying. Ray Bradbury's motto was be out there and visible. How can
yes,
you win if you're not
yes.
out there and visible? He was selling newspapers on street corners in Los Angeles. And somebody said to Ray Brad, he said, "What? Well, what do you do when you're not doing this?" He says, "I'm a writer," he said to some man. This is in the Depression. The guy said back really sarcastic, "You don't look like a writer to me." And Ray Bradbury said, "But I feel like a writer." So there.
I love that.
You like that? Okay, Sarah, I see you got
I
your
need to ask you for
Oh, go ahead.
maybe the last one, because I do have to leave after this one, if
Okay,
that's okay.
Sarah, fast.
Okay, this is actually Jean listening in with Sarah. I was wondering
Okay.
if our speaker has definite favorite science fiction books.
Yeah, for sure. I mean,
And name them.
I would go for authors other than books. Of course, Bradbury. I mean, who could who would deny that? But I really love Ursula Le Guin. I don't know how you say that in English. Le Guin, Le Guin,
Again, yeah.
Le Guin. Okay. And actually, even if it's not science fiction but fantasy, I love Italo Calvino, the Italian writer, who does not add that much science into his books, but for sure fantasy. And it's so well constructed. It's historical fantasy, so well constructed that I love it. He has this science fiction book called The Cosmic Comics or something like that. I don't know how it's translated into English. That has some sci-fi there, but I would go into authors more than that. So yeah, for sure. Of the new guys, this Peter Weir guy, I think, is really doing something very different. The author of The Martian and all of those books, right? So I would go for authors other than stories. And actually, talking about Bradbury, there is a not that well-known short story for kids that he wrote called The Three Astronauts. That I read it when I was a kid, and then I read it to my own sons, and it's one of the most beautiful and sweetest stories that I've read. And so he was really so versatile. He could write whatever he wanted to, right?
Well, I appreciate that you said that because I didn't know Ray Bradbury, but I knew Forey Ackerman, who was Mr.
Yeah,
Sci-Fi and was a good friend. So I got invited to one of his birthdays along with Forey to Ray
yeah,
Bradbury's. But anyway, he was the most unpromising guy. Grew up in the Depression, no money, and
ooh,
from Waukegan, Illinois, which was an industrial kind of a manufacturing town. And nobody thought he had any potential, but he believed in himself. I think his mother did. And he had these experiences, and he wrote. Well, I'll send you the link. It's called
please do. Yeah.
An Evening with Ray Bradbury after his first slight stroke. But what he said is it's all surprise, surprise. And he met this magician in Waukegan who shook his hand and said, "Live forever." And he said, Ray Bradbury said, "I felt the electricity. It was Mr. Electrico went through me, and I knew I would live forever." And he
Wow.
said, "I wish that to all of you." So he was a man of great belief in himself and enthusiasm. But I'll send that link. I think
Please do.
those of you who came today would really enjoy that talk he gave. And thank you so much. This was
Thank you, Gloria.
startling, and just what Bradbury said, it was amazing. Live in the library, he would say. Live in the library. So
Yeah.
you gave the same advice. So
I
thank you
do.
so
Yeah.
much.
Thank you, Gloria, and everybody for the invitation. It was wonderful.
All right. Well, have a good rest of your weekend.
You too. Have to go now then.
Okay. We'll see you later, guys.
Bye, everybody.
Bye-bye.